Okay, this video is the second part of Objective 1 from Motors Module 302C, which talks about 9-lead or dual voltage motors. And you can see by a couple of motor nameplates that we're going to look at here that you will know when you have a 9-lead motor nameplate. Probably the biggest giveaway is when they show a connection diagram here for the low or the high voltage. So 9-lead motors are typically used for dual voltages, almost always 230 and 460 systems. And you'll see this little connection diagram there on the nameplate. Another thing that tells you that it is a 9-lead motor is the fact that there are 2 voltages it can be connected to, 2 currents that it runs at, or other indications that it's a dual voltage or a 9-lead motor. We have the same information on this motor nameplate as well. The connection for low and high voltage. It lists, in this case, it lists 208, 230, or 460, so that this motor could be used on not only a 230 or 460 volt system, but could also be used on 208. Both 208 or 230 volts would use the low connection, and it shows you the different currents for these 2 connections too. This is still really a dual voltage motor, although it can be used on 208 volts as well. When you're done this video, it would be interesting to come back to this motor nameplate and see if you can tell whether it is a Y connected dual voltage motor or a delta connected one. Now, an important thing to know when we talk about dual voltage motors, whether it's Y or delta, is to know how to label the 9 leads that make up the leads for that motor. This is a typical drawing for a Y connected dual voltage motor, and I always think a fairly easy way to remember how to label the leads is to just start on the ends, on the outer ends. Those are always terminal 1, terminal 2, terminal 3. And that's where the 3 line wires will be connected as well. And then to label the other leads, I always start at the end and just add 3 to my numbering. So 1 plus 3 is 4, 4 plus 3 is 7, 2 plus 3 is 5, 5 plus 3 is 8, 3 and 3 are 6, 6 and 3 are 9. So that is a fairly easy way to remember how to label the 9 leads of a Y connected motor. If you wanted to know, if you had a motor that you didn't know was a Y or delta connected motor, but it was a 9-lead motor, you could use an ohmmeter to determine whether it was a Y or a delta motor. And that ohmmeter would show you that you had 3 groups of 2 that had continuity. So 3 windings that have 2 points or 2 terminals of continuity, and 1 group that had 3 terminals of continuity. So when you have 1 group of 3 that have continuity and 3 groups of 2, then you've got a 9-lead Y motor. And the lab that you did on 9-lead Y and delta motors, you did this in the lab as well. Now, for the high voltage connection on a Y connected motor, the high voltage connection will always be the lines connected to terminal 1, terminal 2, line 2 to terminal 2, line 3 to terminal 3. So the lines are always connected to T1, T2, and T3. And for the high voltage connection, we always connect the windings in series for a high, each half of the winding in series for a high voltage connection, which is very similar to multi-winding transformers. When you think about transformer windings that have 2 X windings and 2 H windings, the windings are typically connected in series for the high voltage and in parallel for the low voltage. So for a high voltage connection for this Y motor, the windings are typically connected in series. So 4 would be connected to 7, 5 would be connected to 8, 6 would be connected to 9. That is the high voltage connection. the high voltage connection is really straightforward to do. And then the slide just briefly goes over what the voltage rating for each half of the winding would be. If it's Y connected at 460 volts, the phase voltage would be 265.6 volts. And because each phase winding is split in half, that means each of the winding has to be rated for half that voltage and would be rated for 132.8 volts. For the low voltage connection of a Y connected motor, what we really want to do with the low voltage connection is connect each half of the winding in parallel. So you could draw each half of the winding in parallel with the other half to start this. And then again, the lines are connected to T1. Line 1 is connected to T1. Line 2 is connected to T2. Line 3 is connected to T3. And then the start of each half of the winding is connected together. So T1 and T7 are connected together. T2 and T8 connected together. T3 and T9 connected together. The start of each half of the winding is connected together. And we would like to connect the end of each half of the winding together as well. But we cannot get at this connection here for the second half of each winding. It's an internal connection on the second half of each winding. So if the second half is connected as a Y, all we really want to do is connect the first half as a Y as well. So we can just connect the ends of each of the first halves of the windings together to make it a parallel Y connection. And so 4, 5, and 6 can be connected together to make it a parallel Y connection. What does the rated voltage of each winding need to be in a for the low voltage parallel connection? The line voltage would be 230 volts, so the phase voltage would be 132.8 volts, and each half of the winding would have to be rated for 132.8 volts. One thing to remember about these junction box connections shown here is the circles representing the 9 leads in your motor are often drawn like this on the nameplate. So we can show the drawing as a Y connected drawing, or on the junction box to save space, they'll just show the 9 leads and the connection for low or high voltage. So these connections you need to know for low and high voltage for each motor as well. Now, a delta connected dual voltage motor, this is the standard way to show the stator windings for a delta connected motor. It shows the 9 leads as a delta connection, and you will need to remember how to label this drawing for a delta motor as well. And again, I always would start on the corners, and the corners are T1, T2, T3. That is where the 3 lines will normally be connected. And then from the corners, I just add 3 to my number to label the other terminals. So from the top corner 1, I add 3 to make it 4, my next connection. 4 and 3 is 7. From the corner 2, I add 3. 2 and 3 is 5. 5 and 3 is 8. From the corner 3, I add 3. 3 and 3 are 6. 6 and 3 are 9. So that is a way, again, to remember how to label the 9 leads on a standard delta drawing. And again, to know whether the motor you have is Y or delta, if it's not given on a nameplate or the nameplate has been lost or marked up and you can't tell whether it's a 9-lead Y or delta motor, if you use an ohmmeter, you will see that in a delta motor, you have 3 groups of 3 that have continuity. There'll be continuity between 3 terminals, continuity between 3 terminals here, continuity between 3 terminals here. And you have 3 groups of 3 for a delta motor, whereas in a Y dual voltage 9-lead motor, you have 1 group of 3 and 3 groups of 2. The 460 volt or high voltage connection for a 9-lead delta motor is a very simple connection again. We simply connect each half of the winding in series for our high voltage connection. The lines again, line 1 would be connected to T1, line 2 connected to T2, line 3 connected to T3. And then, just like in a Y, high voltage 9-lead motor, each half of the winding is connected in series. T4 and T7 connected together, T5 and T8 connected together, T6 and T9 connected together. So the motor nameplate for a 9-lead motor will always show the high voltage connection the same, whether it's a Y or delta motor. Now for the 9-lead low voltage connected delta motor, one way you could draw it is to push in the 3 windings so that each half is parallel to each other. And once you've done that, we'll do the terminal numbering. 1, 2, and 3 are the corners. So T1 and 3 would be T4, plus 3 would be T7, T2 plus 3 would be T5, plus 3 would be T8, T3 plus 3 would be T6, plus 3 would be T9. One way to show the low voltage connection for a 9-lead delta connected motor is to show each half of the phase winding next to each other. Then the lines are connected to line 1 to T1, line 2 to T2, line 3 to T3, and then the beginning of each half of the winding is connected together and the end of each half of the winding is connected together for each phase winding. And when you do that, you end up with a connection that looks like this on the junction box, where T1 is connected to line 1 and T7 and T6. T2 is connected to line 2 and to 4 and 8. T3 is connected to line 3 and 5 and 9. That is one way to show how it is connected. I will show you another way that might be a bit easier way to remember it if you needed to draw it out for an exam. You can always memorize this connection, but if you wanted to see it drawn out as well, I'll show you another way. So when we have a dual voltage delta motor that we want to connect for the low voltage, we want to connect each half of the phase winding in parallel. And if I draw my standard drawing for a delta connected 9-lead motor, the way I find easiest to remember how it's connected to be parallel connected is I look at each half of the phase winding and I just say to myself, I want to connect the beginning of each half of this winding together and the end of each half of this winding together. So I will just go from the beginning of number 1 and connect it, go from the beginning of number 1 and connect it, the beginning of each half of the winding connected together, the end of each half of the winding connected together. You can sort of see that each half is connected in parallel now. The beginning of each half connected together, the end of each half connected together. For the second phase winding, or phase winding B, we do the same thing. The beginning of each half connected together, the end of each half connected together. Now each half of this winding is in parallel as well. And the last phase winding C, the beginning of each half of the winding connected together, the end of each half of the winding connected together. So that is another way to show each phase winding, each half of each phase winding connected in parallel. All we would do from there is connect line 1 to 1, connect line 2 to 2, and connect line 3 to 3. And that is another way to show it, and hopefully will help you to remember the connection for low voltage delta if you can just draw the standard diagram and then just draw each half of each winding connected in parallel. This hopefully works well as another way to remember it too. And again, it's important to remember that on the nameplate you will just see the 9 circles for the leads of the 9-lead motor, and you will need to remember for low and high voltage, for delta and for Y, how those leads are connected. And that is 9-lead motors.